Welcome to the Math Path. Thank you for joining us. We will be doing math. But really, thank you, I do thank you for joining us.
Stop it.
I'm so grateful. If anyone is watching these videos, which seems unlikely, especially if people putting their hands in the right. Okay, seriously. How are we going to make any progress on the math path? Okay, so here we are. It has come to my attention that Annabelle does not know about multiplying. Is that true?
No.
That's what you were saying. You didn't know about it how to do multiplication.
But I do.
But you do?
Yeah.
Okay.
But I don't know what it is. I don't remember.
Okay. All right. So, in a previous video, you have seen us do a little bit of dividing and stuff, which you can do. You could do multiplying too, just with the globs. You can do a lot with the globs. You can learn. Please don't put your hands in front of the camera, girls.
That's how That's how the girls are.
All right. Thank you. Don't be moving it around, Kayla. Do we stop the video? No. Yeah. We're going to plow right through. We're going to plow right through. You're going to see this. How it really is. Okay, so we have, this is what, 10. You should know this by now, dear viewer.
Yeah,
this is the magic thing. It's so easy.
But my
10.
hand isn't big enough to do that.
You can do a lot about globs, but, I have the spoiler of what is a number, and we can only maintain kind of support that kind of suspense for so long. And so we're going to let you know, in order to, I feel like once you're really getting into the concept of multiplying and dividing, seriously, no one is listening to me. This is the story of my life, though, but you, dear viewer, are listening to me, presumably. So, once you're really getting seriously into multiplying and dividing, you want to learn about what is a number. To learn what is a number, you introduce the concept of a unit. Look at this idea. So, a unit, because here's what a number is. Are you ready? A number is not just a quantity. It is more than just a quantity. Here, let me take a piece of paper. Do we have a pencil? Someone could give me, Winifred, could you give me a pencil? It's more than just a quantity, because quantity, you don't really need numbers, actually, for quantities. You can just kind of, number is overkill for that. You know, just like count them or whatever. Have rocks represent your cows, and whatever. You keep track of them, kind of. So you don't actually need a number. So Euclid talked about this. It's a little abstract, but we'll show you the best we can. So let's say you have two lines. There's two quantities, right? One is longer than the other. That's about all you can say about them. You don't know how much. Hold it up so it's kind of above. Look, here they are. Okay. And you can compare them and stuff, whatever. You can do different things with quantity. You can actually do all the arithmetic operators with just quantities, not numbers. You can split these up. You use your compass. You use your ruler, whatever. Not ruler, straight edge. Ruler has numbers. Okay. So, to get numbers, what a number is a quantity measured by another quantity. It's a quantity in terms of another quantity. So let's look at this. Let's say you had a quantity,
there are 10
boom, like this. That's exactly
Uh-oh, it's low battery.
Yeah, it always gives that. That's okay. That's exactly 1/4
It's
of
only like
this one.
10%. Yeah, I don't
It
know if
wasn't
it's
really
even... Yeah, I can't do this.
So there we go. So see, then you have a number. You have this. If you call this your unit, and you call this is something else in terms of that unit. Okay, so you're measuring this line in terms of that line, and you say it's 1, 2, 3, 4. 4 over 1. Okay. Or if you had a bigger unit, maybe like this, okay, then you could take that as your unit and you could measure this, and you could say, well, that's 2. 2 in terms of, if this is just your 1, maybe it's just 2 in terms of 1. But if you know about this one, and you're still kind of using that as your unit, then this is actually 2, right? And so then you're saying, if you're measuring it in terms of this, then your ratio, key concept is 4 in terms of 2. And it's all implicitly kind of over 1, like 4 over 1 over 2 over 1. You can just cancel out all the over 1s. So, why does all this matter? Anyway, it's because this is what a number is. A number is a ratio. In other words, it's a quantity, a measurement, an exact measurement in terms of some other quantity. An exact measurement, okay? So, a number is always exact, by the way. All right? It's like, this is exactly what it is. So, if we have this 10, all right, you're working with globs, you have had sort of implicit your unit. Your unit is 1. Everything's in terms of 1. So here's how we will represent what the unit is that you're working with. See, you wrap a rubber band around it. And so this is 10 in terms of 1. Now, what if you did this? What if you did this, Annabelle? What if you made the unit 3? So now, this is your unit. So you're going to measure everything in terms of 3s. How many 3s are there? So then, what do you have? What do you have here?
You have 3 3s, but 1 1.
Whoa! You did that without even moving them around. Okay, let's move them around and show the people. She's exactly right. I didn't really think she would know that.
And 1 1.
You got a 1 left over. Okay. And so you could just say 10 3s or 10 thirds. Pretty accurate. Math teachers love you to reduce, or what do you call it? Simplify. I don't know. Whatever you do with the fractions to make it so you have some whole numbers, and then you have the leftover. At least they did when I was in elementary school. And so then you have 3 wholes, and this is called, this 1 leftover, you're measuring this 1 in terms of 3. And so we call this 1 out of 3, or 1/3. So this 1 in terms of 3, 1/3. Okay, so we'll have 1, 2, 3, and 1/3. Because this is 3 in terms of 3, so that's just 1. There's another 3 in terms of 3, there's another 3 in terms of 3. So you have, 1, 1, 1. You can make these into, guess what? It looks like a 3, right? See the triangle?
Yeah. And
You
then
can make a triangle of triangle, right? So it's 3 3s. So this is all connected in a way that I'm not very well explaining right now, because whatever, I've been working 10 hours and stuff today, but I hope it makes some sense to you. Fractions division, multiplication, it's all connected. It's the three things that are kind of very much related. Because you can, okay, so let's say you're doing 8. This was my idea when I was thinking of this at work. Okay, so you say it's at 8. Okay, we saw about how divide this by whatever, and you can divide it into how many groups. What if instead the fraction is kind of the more static part? What if you, instead of knowing how many groups you want to divide it into, you know what size the group is that you're going to divide it, but you don't know how many groups they're going to be. You just know how big the group's going to be. Or you know how big the group, the glob will be, but you don't know how many globs there's going to be. So, get this on there. So what if you had this? This could be a way of saying, okay, we have 8. We have our ice cream cone, and we want to say 8 in terms of 4. 8 in terms of 4. See, so in that sense, a ratio is a little bit different than division. There's not necessarily an action going on. You just want to state what is 8 in terms of 4. So what would it be?
It would be 2 4s.
It would be 2 4s.
2 4s.
There they are. 2 of them. Womp, womp. Whoa, what do you... No. Come back on the 4s, Caleb. Show us the... Are you seeing it? Can you see them? There they are. 4. So, there's 2 of them. So, it's kind of... Fraction and division, you could say it's the same thing, or maybe you could say it's not exactly the same thing. You divide 2, you divide by 2, or the 4 is you are 4, what do they divide into? And multiplication is very similar. Look at what I've done. I made these little things. So just like you can have the shapes, you can do that. There's only so many of these objects. They're going to have whatever object you're going to use. Find something, that's roughly identical. But look, you can put little toppers on these and say, okay, these are all going to represent 3, right? And so, look, if each of these, hey, Annabelle, so if each of these were 3, and how many do you have of them?
I have 4 3s.
You have 4 3s, and so then how many is that?
Would be 12.
12. You know that?
Yeah, 6
You
plus
knew that
6
one?
is 12.
6 plus 6, and so you added the 3s and stuff. Yeah, and it would be easier to do it with the manipulation or whatever, but then at some point you're memorizing them, right? You're memorizing them, and so you can make little flashcards with something like this. And then you can also do the division in a similar way. Instead of having the 3 all filled in, you could have just one of them filled in and the other 2 empty. And then it's like, okay, you're taking 1. If each one of these was 3, you split it into 3, or, you start off with this. This is your unit, okay? And then if you're going into fractions, and then you say, well,
Quiz Daddy on math in the math pass.
split it into each one into 3. So you have 1 third, 1 third, 1 third, 1 third, and you can put them together, and you have 1 and 1 third, or 4 thirds, if you were going to take 4 divided by 3. Basically, nothing happens when you take 4 divided by 3. 4 divided by 3 equals 4 over 3. It equals 4 thirds. There's not actually any thing that you do, because you can't measure 4 by 3 in an even way. So you say it's 4 in terms of 3, which that's all there is to say about that. And you could make it into a whole number plus the leftover. Sometimes that's nice, sometimes it's not. It just kind of depends. So there's division, multiplication, fractions, and what is a number? Thank you for joining us. Have a wonderful day. And guess what? It's September 26th. It's 3 months till day after Christmas. We missed yesterday's episode. Say 3 months till Christmas. But now it's 3 months till the day after Christmas. Bye-bye.